let's take a look at the mean or expected value for a discrete random variable. When we use the word mean in statistics, obviously it's like the average outcome that we would expect to get. It can be worded in a couple of different ways. You could say what's the expected value from the distribution, what's E of x, which means the expected value, or they could just use the word mean or average. The formula that we're going to use, it looks like this. So if you want to find the expected value or the mean, it's the sum over all the x values, so whatever the discrete x values are in the question, and we multiply the outcome, or the actual x value, by its associated probability. So we'd be doing 0 times by 0.4, 2 times by 0.3, 8 times by 0.2, 10 times by 0.1. And before we just jump into this, like, and start doing the calculation, it's a relatively straightforward calculation. Let's just get a feel for like what this formula is telling us. Okay, because it can help, I think, to remember. Imagine we had an outcome, a distribution that looked like this. So x, the probability, and let's say we could get a 4 or a 5. So whatever this is, it might be like a spinner, and you're either going to get a 4 or you're going to get a 5. Probability of each of those things, let's keep it dead simple. So 0.5, even chance of you getting a 4, even chance of you getting a 5. What would the average outcome be then? If you got a load of 4s and you got a load of 5s, each of them was evenly distributed. And so what's the mean? What would you expect? Like on average, what would you expect to get? Can we all see that the answer would be the expected value of x would be 4.5? Because you'd expect to get 4 half the time, 5 half the time. But the calculation that lies behind this, that's the intuitive thing that we're doing. You multiply the outcome by its associated probability. If we do 4 times by 0.5, and if we do 5 times by 0.5, that would give us 2 plus 2.5. In other words, the 5 is contributing like 2.5 towards the total, the 4 is contributing 2 towards the total, and that'd be 4.5. Okay, let's say if we start adjusting the probabilities and see how that would affect it. So if the probability of a 4 was 0.1, then the probability of 5 would be 0.9. So let's say you're much more likely to get a 5. What do you think would happen to the expected value in this situation? Like, would it stay the same as 4.5, or would it change? I think we can all agree that on average, because you're going to get more 5s, the average outcome would be higher, wouldn't it? It'd be closer to 5 than it was previously. Okay. If we do the calculation, if we do 4 times 0.1, that would give us 0.4. If we do 5 times by 0.9, that would give us 4.5. So if we add these together, in this situation, the average outcome or the expected outcome would be 4.9. And you might have been able to see that it was going to be 4.9 just intuitively. All right, and that's all that we're doing when we do this calculation. Like, if you want to get the expected value or the average outcome, you just multiply the event by its probability and add them up to see what we get. So for this one, we've got discrete random variable. We could get a 0, we could get 2, we could get an 8, or we could get 10. Probabilities associated are this, and I should actually write the question out, shouldn't I? This one just says find E of x, so find the expected value or the mean. Show your calculation here, because obviously if you make it like a small numerical error, you'll lose like 2 or 3 marks on this. Like, show the method as well. So 0 times by 0.4 plus 2 times by 0.3 plus 8 times by 0.2 plus 10 times by 0.1. So that'll give you your method mark, and then you can reach your calculator to get to the answer. And that would give us 0.6 plus 1.6, so 2.2 plus 1, so 3.2. And obviously just you can try and get a feel for these statistics questions. Like, does that seem like a sensible answer? Like, if I got like 7 out or 25 or minus 3, like, I think we can see that, like, because the events, the chance you're either going to get a 0, 2, an 8, or a 10, and most of the probabilities, most of the outcomes are going to be down here. There's a good chance you're getting a 0, there's a good chance you're getting a 2. It's slightly skewed by the fact that the 10 is quite a bit higher, but you don't get many of them, do you? So, like, on average, the outcome that we would expect to get would be 3.2. Obviously, you're never going to get a 3.2 out, but that's like if you spun the spinner loads of times and then average those out, the average would be somewhere around about 3.2. Next, let's take a look at not just the expected value of x itself, but the expected value of a function of x. Okay, so if it's the expected value of x, we multiply the x value by its probability, but if it's an expected value of some sort of function of x, we multiply the probability by this function of x. For example 1, we're given the discrete distribution, which could be 0, 1, 2, 4, or 5, and the associated probabilities are like so. We're asked to calculate a few different probabilities, a few different expected values. Let me just write those out. Okay, first thing we're going to find is just the expected value of r. So the expected value of r would be 0 times by 0.2 plus 1 times by 0.15 plus 2 times by 0.35 plus 4 times by 0.2 plus 5 times by 0.1. Again, show the calculation because you're going to get your method mark here. Okay, use your calculator if you need to, and it's a good idea to check because obviously I'll try and do this in my head, but if I make a little mistake here, I'm throwing away marks in the exam, aren't I? So 0.15 plus 0.7, 0.85 plus 0.8, 1.65 plus 0.5, so that would be 2.15. The next thing then, this is where it's slightly different. So if you want to get the expected value of r squared, that would be the sum, or the function that we're working with in this question is r squared. So it would be the sum of r squared times by the associated probability. Again, try and give you a bit of an analogy or a way to think about this, like instead of it just being so abstract. Like our original spinner, what's that? Our original spinner once has got 5 sides, failure drawing a 5-sided shape, and you could originally have got 0, 1, 2, 4, or 5 on this spinner. Okay, but now when the function changes, and we're going to see this a lot in the next couple of questions and videos. If the function changes, the way I think about it, it's like the number on the spinner has changed. So the spinner doesn't have 0, 1, 2, 4, or 5 on it anymore. Like the value itself would be 0, 1, 4, 16, and 25. And a key thing to realise on this, moving forward as well, and other styles of questions, if the function changes, you might want to draw it in your table if you want. Okay, for this one I'll show you what the table would look like. So the really important thing to realise moving forward on this topic is when this changes, the probabilities don't change. Like that would still be 0.2, that would still be 0.15, that would still be 0.35, that would still be 0.2, and that would still be 0.1. Okay, but the actual outcomes from the distribution have changed. Like r was 0, 1, 2, 4, or 5, but now r squared, the spinner, it could give you a 0, it could give you a 1, it could give you a 4, it could give you a 16, it could give you a 25. Okay, so when this function changes, the associated probabilities stay the same. Like the spinner itself didn't change, but the outcomes on that spinner did change. Hopefully that helps. And essentially all we need to know is how to actually do the calculation. So expected value of r squared. If you don't draw a new table out, and when you get used to it, you won't need to for every question, it would just be 0 squared times by 0.2 plus 1 squared times by 0.15 plus 2 squared times by 0.35 plus 4 squared times by 0.2 plus 5 squared times by 0.1. I'm going to reach for the calculator here, so let me just see what that gives us. Okay, I'm getting 7.25 if I've put the buttons correctly. Really important to realise that e of r squared is definitely not the same as the expected value of r squared. I mean, there might be a weird distribution where they make it up so that this does happen, but in general, e of r squared is not this e of r squared, so don't just think you can square this. Like, the numbers in the distribution have changed, so it affect the outcome that you would get, wouldn't it? Okay. Next one is the expected value of r cubed. Again, the outcomes would change, the probabilities would stay the same, but that is just the sum of r cubed times by the probability, so 0 cubed times by 0.2 plus 1 cubed times by 0.15 plus 2 cubed times by 0.35 plus 4 cubed times by 0.2 plus 5 cubed times by 0.1, and this is going to be quite significantly larger, because if you think about it, because that 5 at the end, even though the probability of it happening is only 0.1, when we cube that value, that's going to, significantly increase the average outcome that we would get. The average is going to be higher because the numbers on the spinner are going to be higher, aren't they? Okay, so that gives me 28.25. Yeah, the last one is the expected value of r squared plus 2r. I'm going to use a little shortcut, which we'll see later in the next couple of videos. You could try and visualize this. Like, if you think about it, if you adjusted these numbers, so it would be like, let's do it with 2 squared plus 2 times 2, like that outcome there with that associated probability, it would be the same as doing 2 squared times by 0.35 plus 2 lots of 2 times 0.35. So because the 0.35 is being counted with the r squared and it's been counted with the 2r, like, it allows us to split this up, and that would be equivalent to the expected value of r squared plus 2 lots of the expected value of r. And we already know those two things, so we can just literally split it up like this. I mean, if you didn't spot that, it's not a problem. You can just do, that would be the same as like 0 squared plus 2 times 0, the function itself times by the probability, plus 1 squared times 2.1, etc, etc. And that would just, but this is like a quicker way and maybe a slightly more intuitive way to think about it. Okay, so expected value of r squared was 7.25. And 2 lots of the expected value of r, which was 2.15. So that would give us 7.25 plus 2 times 2.15. 11.55. Possibly check and do the calculation the other way as well, make sure you get the same answer. But you could also believe me, it will, and we'll see that later. Alright, thanks guys.